Hello, so in today's video we are going to be talking about linear approximation, and that is an application of derivatives. Linear approximation is simply the approximation of a certain function using a linear function. Let's take a look at this graph. We have a function f of x, and we have drawn at point A a tangent line labeled L of x. So we can see that if we zoom into that point at x is equal to a, we can see that the tangent line L of x is very similar to the function f of x at the given point. So we can use this tangent line L of x to approximate any function close or near to x is equal to a. So what is this going to look like? Keeping in mind that L of x is a tangent line, we are going to use the equation of a tangent line to derive the linear approximation formula. So we know that the equation of a tangent line can be written like this. Y minus y1 is equal to the slope m times x minus x1. Now let's rewrite this in terms of our graph that we just looked at. In this case, instead of y, we're going to have L of x. Instead of y1, we're going to have f of a. And that's going to be equal to the slope. We note that the slope is the derivative. So f prime of a times x minus a. And we can rewrite this as L of x is equal to f of a plus f prime of a times x minus a. And that is our linear approximation formula. So let's solve an example applying this formula so we can understand what it really means. So let's take a look at this question. Estimate g of 1.2 minus g of 1 given that g prime of 1 is equal to 4. So how do we apply our linearization formula into this question? So in this case, our L of x is our g of 1.2. So g of 1.2 is equal to g of 1 plus g prime of 1 times 1.2 minus 1. Now, to find what g of 1.2 minus g of 1 is, we can simply rewrite the formula as g of 1.2 minus g of 1, that is equal to g prime of 1 times 1.2 minus 1 is equal to 0.2. And we are given that g prime of 1 is equal to 4. So 4 times 0.2 is equal to 0.8. So we can actually come up with a simple formula that can help us skip a few steps. So instead of having to write the entire formula, we can just write the difference in two formulas. Delta f is equal to the derivative f prime of a times the difference in x, so the change in x. So using this formula, we can apply it in future questions and not have to write down the whole formula. So let's take a look at this question. We are asked to estimate f of 3.2 minus f of 3 given that f of x is equal to x squared. So there's a few more steps in this question, but given the formula that we just derived, delta f is equal to f prime of a times delta x, we can solve this simply. So let's start by defining some of these terms in our questions. Our delta f in this case is f of 3.2 minus f of 3, and our delta x is equal to 3.2 minus 3, or 0.2. Now, our f prime of a in this case is going to be f prime of 3, which we are not given, but we can derive from the formula or from the function given to us, which is f of x is equal to x squared. So, if f of x is equal to x squared, we can take the derivative because this is a fairly easy function. So f prime of x is 2x, and we get that using the power rule. So we multiply the power by the constant, and then we subtract them from the power. So it gives us 2x. And now we want to look specifically for f prime of 3. So we just substitute that into the equation. So 2 times 3 is equal to 6. And now we just plug everything into our linearization formula. So delta f, or the change in f of 3.2 minus f of 3, is equal to 6 times 0.2. And that is equal to 1.2. In summary, linear approximation is merely a tangent line equation. So if you ever forget what linearization is, as long as you know the equation of a tangent line, you can very easily derive it and apply it. And we use linear approximation to help us with approximating certain functions as long as we are near the point x is equal to a. The further we are, the larger the error is going to be. And we apply linear approximation in many fields like physics, and we use it in projectile motion and even Ohm's law.